We began this module listening to Joe Bowler talk about how anyone can be a math person. And then I had you respond to something that Joe said and ask you, how do we unlock the unlimited mathematics potential for our students? And then I had you take a dive into using two representations that are vital actually in the classroom to building a student's sense of number and algebra by looking at base 10 blocks and algebra tiles. When you include representations in the classroom, you open up the questions to allow learning to occur and to deepen a student's understanding of number and algebra. And so why did I choose those two representations, base 10 blocks and algebra tiles? Well, let's look at why I chose both of those, and let's make a connection. So we're going to begin and look at the number 342. And in elementary school, students learn how to compose and decompose numbers. And so they would decompose this number and look at 3 times 100 plus 4 times 10 plus 2 times 1. They would look at the number 342 by place value. I have 3 100s, 4 10s, and 2 1s, and when I add it together, I get the number 342. Well, let's take this a little bit further because we work in base 10. So we could actually represent this number as 3 times 10 squared plus 4 times 10 to the 1 plus 2 times 10 to the 0. And now we're looking not just at place value, but we're looking at place value utilizing base 10. So if I look at 100 in base 10, the tens place in base 10, and the ones place in base 10, because 10 to the 0 is 1. Let's see if we could make a connection here to algebra tiles. We don't combine our tens with our hundreds. It's a different place value. We don't combine our ones with our tens. It's a different place value. We may regroup, but we don't add those or combine those together. So if we're looking at algebra tiles and instead of working in base 10, we work in base X, we can help students understand why we can't add an x to an x squared term or a constant to an x term. Because when we're working with algebra tiles in algebra, our base is x, but it operates the same as when we're working in base 10. Mind blown? I hope so, because it sure was a revelation to me whenever I understood the connection between base 10 blocks and algebra tiles. If you have any questions, please reach out.